Hello, calculus. Hope everybody's having a fantastic day. Not a lot of time, so let's jump straight into it. This is going to be a relatively simple lesson. We're going to be evaluating the integrals of e to the x and the natural log of x. So to start off, just pulling something into from what we already know, example 1 here. This doesn't have anything to do with the natural log of x. It doesn't have anything to do with e. This is just a straightforward question using u substitution with a definite integral. So we have limits of integration 1 to 5. Let me zoom in here. There we go. So the first thing I'm going to do is call u 2x minus 1. So du is going to be 2 dx. All right. And we don't have a 2 outside of my u value, so I'm going to have to get rid of that. So we'll call this 1/2 du is dx. So this guy right here is 1/2 du. And then we need to come up with our value for u itself, or excuse me, for x. So we're going to use this guy right here. U equals 2x minus 1. So u plus 1 equals 2x. Remember, I'm trying to come up with this value for x. So x is u plus 1 over 2. And that's this guy. U plus 1 over 2. So that pretty much takes care of everything with the exception of our limits of integration. So let me go ahead and draw my integral symbol. And this is going to be u plus 1, a little bit far in there. There we go. It's going to be u plus 1 over 2 times, and this is u to the 1/2, but it's in the denominator, so I'm going to call it u to the negative 1/2. Excuse me. Du. And now I need to fix my limits of integration. See, originally my x's were going from 1 to 5. So I'm going to come up with my u values here. So 2 times 1 minus 1 is going to be 1. 5 times 2 is 10, minus 1 is 9. So instead of going from 1 to 5, my u substitution will go from 1 to 9. And then I can come over here. This should all be, this is stuff that we learned in the last lesson, so this is just kind of a refresher here. U to the negative 1/2, blah, 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 blah. What are we doing here? We've got, let me go ahead and draw my integral from 1 to 9. And we can simplify this. We have, oh, the 1 over 2. I forgot the 1/2. See, and that's where we can get in trouble. I was sitting here looking at it, and I thought, I forgot something. There it is. So again, we talked about this beforehand where this is kind of like if you do this over 1, multiply it all together through the top. I'll take this slow for the first example here. This is kind of like u plus 1 times u to the negative 1/2 du, and that's over 2 times 2 over 4. So we can pull that 1/4 out and bring it outside of the integral, get rid of it under here, right? So what that's going to leave me with then, I'm going to come down here and write this. We have 1/4, the integral from 1 to 9 of, and I'm going to go ahead and multiply this out. U times u to the negative 1/2 is u to the 1/2. U to the negative 1/2 times 1 is plus u to the negative 1/2 du. And let's go ahead and integrate this now. We've got good integration symbols everywhere, good limits of integration. I've got my du's everywhere. I'm ready to go. So this will be 1/4. Integrate u to the 1/2 is u to the 3/2 over 3/2, which will be 2u to the 3/2 over 3 once we simplify that 3/2 down here. We simplify it and bring up the 2. I'm just going to kind of go over that step here. And then plus u to the 1/2 over 1/2. So it'll be 2 u to the 1/2 over 1. And I'm going to integrate that from 1 to 9. All right, so let's see what we get here. I've got the 1/4 still out front. And this is going to be plugging in 9 first. We've got 9, square root of 9 is 3. 3 cubed is 27. Divided by 3 again is 9. Times 2 is 18. Plus 3 times 2 is 6. Minus plugging in 1. That's 2/3 plus 2, which is 1/4. All right, 18 plus 6, 2/3 and 2, 3, that's going to be 16/3, I believe. No. That's after the 1/4. Here, let me just do this. That whole thing simplifies down to 16/3. Awesome. All right. Let's do this. Now, when we're dealing with E values, it's going to be the same process. The only difference is we have an E, so we have to remember those special rules that deal with E. So I'm going to go ahead and label my U. So U is x squared du, let me see if I can pull that brightness down just a hair. Du is going to be 2x dx. All right, and I don't have a 2, but I do have an x. Well, that makes it easy for me here. I don't have a 2, so I just do a 1/2 du, and that'll get rid of my 2 there. And I've got an x dx, so this is going to be the integral of e to the u times 1/2 du, and you can go ahead and bring the 1/2 out. You know that by now, hopefully. And then I fix my limits of integration here, right? Let me see what I get. I have x and u 0 to 2. So if you plug a 0 in here, 0 squared is 0. Plug a 2 in here, 2 squared is 4. So it's 0 to 4. And that's going to pull out that 1/2 there. That's going to be the integral of 0 to 4 e to the u du, which is 1/2. And this is why everybody likes integrating e to the u from 0 to 4. Because remember, the antiderivative of e to the u is e to the u. Yay! All right, and then we have integrating from 0 to 4, so this is 1/2 times e to the 4th minus e to the 0, and e to the 0 is 1, right? So the whole thing is going to end up being e to the 4th minus 1 over 2, or times 1/2, however you want to write it. Either way you come up with it is perfectly fine. Not bad. That's why everybody likes integrating E. Integrating and deriving E, man, it's good times. All right, what about example 3? Okay, now the first thing that I see when I pick this thing up is my value of x down here. That value of x being a -1, when I integrate that, is going to make it a value of x to the 0, which ends up being 1, which I can't do that. That just gives me a constant value, right? So we learned a few days ago that what I'll have to do first is the integral of 1 to the x. Let me turn back there and show you. The integral of 1 to the x, or 1 over x rather, is the natural log of x. So the integral of 1 over x is the natural log, absolute value of x, and that's evaluated from 1 to 3. We'll get into it a little bit more about using u with the natural log. It's a little bit more not complex, but just detail oriented. So for right now, I just wanted to start you off on something a little bit more simple. So this is the natural log of the absolute value of 3. Remember, this is f of b minus f of a, natural log of the absolute value of 1. Now the absolute value of 1, let's go ahead and rewrite this here. It's the natural log of 3 minus the natural log of 1. Take your absolute values away, make them positive, all that jazz. The natural log of 1, if you'll recall, is 0. Remember that the natural log function goes through 0, 1, up like this. All right? So if you plug a 1 in for your x value, then you get 0. So this whole thing is just the natural log of 3. So just a few quick, easy questions to get you started in the right direction. And from here, we will call it a day.